How microplastics affect human. In everyday life, full of convenience, we find plastic anywhere we look. Have you ever pondered what are various aspects of plastic? Share your thoughts with others. What consequences it brings to our life and well-being. It is really worth few moments to ponder together. The ubiquitous presence of microplastics and even smaller nanoplastics in our environment has emerged as one of the most pressing environmental and health concerns of our time. Have you ever wondered why something about our own or our pets' wellness squares less and less? Here you find some interesting and important answers. Let us know what is your approach to this subject. With this video we share our view and concerns. Then it's your turn to do it too. These microscopic fragments, generally defined as plastic particles smaller than 5 millimeters, are products of the breakdown of larger plastic items, as well as intentionally manufactured particles found in cosmetics and industrial products. They are now found in virtually every corner of the globe, from the deepest oceans to the highest mountain peaks, and critically, in the air we breathe, the water we drink, and the food we eat. The alarming reality is that these tiny invaders are no longer just an environmental problem. They are infiltrating the bodies of humans and animals, raising profound questions about their long-term health consequences. Microplastics find their way into living beings through several primary routes. Ingestion. Food and water is a major pathway. Microplastics are present in bottled water, often at higher concentrations than tap water, seafood, especially filter feeders like mussels and oysters, and fish that ingest them, salt, honey, sugar, and even beer. Animals ingest them directly from contaminated environments, like marine life in polluted waters, or through their diet. Food chain transfer, trophic transfer. A crucial mechanism of accumulation. Smaller organisms, like zooplankton, ingest microplastics, and then these particles are transferred up the food chain as larger animals consume the smaller ones. This process can lead to the bioaccumulation of microplastics, and potentially the associated toxins, in organisms at higher trophic levels, including humans who consume these animals. Inhalation. Airborne microplastics, generated from synthetic clothing, tire wear, industrial processes, and the breakdown of outdoor plastics, are a significant source of exposure for both terrestrial animals and humans. These particles can be inhaled into the respiratory system. Dermal absorption. While less understood, there's emerging evidence suggesting that nanoplastics, particularly, might be able to penetrate the skin, especially if the skin barrier is compromised by inflammation, aging, or injury. This route could be relevant through cosmetics or contact with contaminated materials. Once inside the body, the fate of microplastics depends on their size, shape, chemical composition, and the presence of any adsorbed contaminants. Larger particles may be ingested, but smaller particles, especially nanoplastics, less than 1 micron, are more likely to translocate from the digestive or respiratory tracts into tissues and organs. Effects on humans. A growing body of concern. The research on human health impacts is still in its early stages compared to animal studies. Check our short video on this subject. The findings are rapidly accumulating and raising serious alarms. What is being observed in animals is largely believed to have implications for humans due to shared physiological mechanisms and the pervasive nature of exposure. Ubiquitous presence in human tissues and fluids. Blood and organs. Microplastics have been detected in human blood, lungs, liver, kidneys, spleen, and even the brain, suggesting systemic circulation and accumulation within the body. Reproductive system. Disturbingly, recent studies have found microplastics in human ovaries, follicular fluid, surrounding eggs, testicular tissue, and seminal fluid. This raises significant concerns about potential impacts on fertility and reproductive health. Placenta and breast milk. Microplastics have been found in the human placenta, indicating that they can cross this vital barrier, potentially exposing developing fetuses. They have also been detected in breast milk, suggesting a potential pathway of exposure for infants. Meconium. Even a newborn's first stool, meconium, has been found to contain microplastics, indicating prenatal exposure. Suspected health impacts, based on animal and in vitro studies, and emerging human data. Inflammation and oxidative stress. Similar to animals, microplastics in human cells and tissues can trigger inflammatory responses and increase oxidative stress. Chronic inflammation is a known contributor to numerous chronic diseases, including cardiovascular disease and cancer. Cellular and DNA damage. Microplastics, especially nanoplastics, have been shown in laboratory studies to cause cytotoxicity, damage to cells, and genotoxicity, damage to DNA. DNA damage is a precursor to cancer and other cellular dysfunctions. Cardiovascular health. A landmark study in 2024 found that individuals with microplastics in the plaque removed from their carotid arteries had a significantly increased risk, more than double, of suffering a heart attack, stroke, or death over the next few years compared to those without microplastics. This suggests a direct link between microplastic accumulation and cardiovascular disease progression. Neurological concerns. The detection of microplastics and nanoplastics in human brain tissue is particularly concerning. Nanoplastics can cross the blood-brain barrier, a protective shield for the brain. Scientists fear this could lead to neuroinflammation, potentially contributing to neurodegenerative conditions like Alzheimer's or Parkinson's, and impairing cognitive functions like memory and learning. Reproductive and hormonal disruption. The presence of microplastics in reproductive organs and fluids raises fears about their potential to disrupt egg maturation, sperm quality, and hormone production. This concern is amplified by the fact that microplastics can carry endocrine-disrupting chemicals, EDCs, that leach out. These EDCs can mimic or interfere with natural hormones, potentially leading to reduced sperm counts in men, impaired egg quality in women, early puberty in girls, thyroid dysfunction, increased risk of hormone-sensitive cancers, e.g., breast, prostate. Adverse pregnancy outcomes. Scientists suspect microplastics may contribute to cancer in several ways: by acting as carriers for carcinogens, by directly causing DNA damage, and by inducing chronic inflammation, all of which are known pathways to cancer development. Respiratory issues. Inhaled microplastics can lodge in the lungs, potentially leading to inflammation, tissue damage, and respiratory disorders, including an increased risk of lung cancer. Immune system effects. While still being researched in humans, animal studies suggest microplastics can modulate the immune system, potentially making individuals more susceptible to infections or autoimmune responses. Aging processes. Nanoplastics have been linked to cellular senescence, a process where cells permanently stop dividing, often associated with aging. This could lead to cumulative tissue damage and reduced regenerative capacity over time. The unseen threat. Nanoplastics. The even smaller nanoplastics, particles typically less than 1 micrometer, often down to the size of viruses, pose an even greater concern than microplastics. Their minuscule size allows them to cross biological barriers. They can more easily pass through cell membranes, the blood-brain barrier, and the placental barrier. Accumulate deeply. Once inside cells or organs, they may not be readily excreted and can persist for extended periods, leading to prolonged exposure and potential damage. Greater surface area. For their mass, nanoplastics have a larger surface area, potentially allowing them to carry and leach more adsorbed chemicals or trigger more intense cellular reactions. The evidence is mounting that microplastics and nanoplastics are not inert passengers in our bodies or in the environment. They are active agents, capable of causing physical harm, carrying toxic chemicals, triggering inflammation, and disrupting crucial biological processes in both humans and animals. While research is ongoing to fully understand the long-term, synergistic effects of these particles and their chemical payloads, the current findings are a stark warning. Reducing exposure to microplastics is becoming an increasingly important aspect of personal and public health. This includes minimizing single-use plastics, especially in food and beverage packaging, opting for glass, stainless steel, or ceramic alternatives for food storage and heating, filtering tap water, choosing natural fibers over synthetic ones for clothing, avoiding personal care products with microbeads. The interconnectedness of ecosystems means that plastic pollution affecting wildlife ultimately impacts human health through contaminated food chains and a degraded environment. Addressing the microplastic crisis requires a global, multifaceted approach, emphasizing not just waste management, but also fundamental changes in plastic production, consumption, and disposal to safeguard the health of all living beings for generations to come. The silent invasion of microplastics is a powerful reminder that environmental health is inextricably linked to our own well-being. We hope this video brings to you some more awareness, and you will start to protect your well-being and well-being of your dear ones even more than before. Even though this video may sound as alarmistic, it just brings information everybody who wants to be well should consider in their life. Do you agree? Like it, share it, and subscribe to our channel for more videos not only like this one. Check the ones about coffee or dogs. Until next time.